Good morning, students. In this class, we will see about Bravais lattices. In the last class, we read about what are the nature of matters. There are four types of matters. One is solids, another one is liquids, another one is gas, and another one is plasma. So these are the four fundamental types of matter. Then we saw about what is a crystal structure, what is a basis, what is a lattice, and what are space lattice and point lattice, etc. So now we will see Bravais lattices. So what is the definition for Bravais lattice? The number of lattices that can fill 2 or 3 dimensional space without any gaps or with limited overlaps with periodically repeating unit cells are called Bravais lattices. So Bravais lattices are nothing but the number of lattices that can fill 2 or 3 dimensional space. That space may be a 2-dimensional space, that space may be a 3-dimensional space. That space should be covered without any gaps. If there is any gaps, then with limited overlaps with periodically repeating units are called Bravais lattices. So what is the definition? The number of lattices that can fill 2 or 3-dimensional space without any gaps or with limited overlaps with periodically repeating units are called Bravais lattices. These Bravais lattices gives finite number of different crystal structures. These Bravais lattices give finite number of different crystal structures. In Bravais lattices, there are 2-dimensional Bravais lattices and 3-dimensional Bravais lattices. 2-dimensional Bravais lattices and 3-dimensional Bravais lattices. In 2-dimensional Bravais lattices, there are 5 types. In 3-dimensional Bravais lattices, there are 14 types. So in 2-dimensional Bravais lattice, there are 5 types. In 3-dimensional Bravais lattices, there are 14 types. So now in this class, we will see what are 2-dimensional Bravais lattices and what are 3-dimensional Bravais lattices. Okay, first we will see now Bravais lattices in 2 dimensions. We already told there are 5 types of Bravais lattices. Here, how these Bravais lattices will be differed? That is with respect to structure, how it is differed. Here A, B, C represents the sides of a structure. Alpha, beta, gamma represents the angles. So A, B, C are sides, alpha, beta, gamma are angles. Here 2 dimension means only x-axis and y-axis only. Similarly, alpha or beta or gamma angle only varies. Otherwise, it will be same. Okay, what are the 5 types? Oblique lattice, square or rectangular lattice, primitive rectangular lattice, centered rectangular lattice, hexagonal lattice. So there are 5 types of 2-dimensional Bravais lattices: oblique lattice, square or rectangular lattice, primitive rectangular lattice, centered rectangular lattice, hexagonal lattice. So these all lattices will differ with respect to the sides and with respect to the angle. With respect to the sides and with respect to the angle. Now we will see one by one. Oblique lattice, that is the 2 sides are not equal and the angle gamma is not equal to 90 degree. If the structure is like this, then it comes under two-dimensional oblique lattice. Okay, so oblique lattice, A is not equal to B and gamma is not equal to 90 degree. These type of lattices are called oblique lattice. The oblique lattice is the most general and least symmetric Bravais lattice in two dimension. Oblique lattice is the most general and least symmetric Bravais lattice in two dimension. Okay, so A is not equal to B, gamma is not equal to 90 degree if it is called oblique lattice. Now you see, square or rectangular lattice. Square means all the sides are equal. Rectangle means length and width are different. Sides are different lengths. Okay, so it is the difference we already know. So square or rectangular lattice. If it is a square lattice, then A is equal to B and gamma is equal to 90 degree. If it is a rectangular lattice, A is not equal to B but gamma equal to 90 degree. This is the difference. If the angle between the two lattice vectors is 90 degree, the Bravais lattice could be whether rectangular or square depending on whether the unit cell vector have different lengths or not. So different lengths, then it is rectangular, same lengths, then it is a square. But in the case of rectangular lattice, there will be two types: primitive rectangular lattice and a centered rectangular lattice. Primitive rectangular lattice and a centered rectangular lattice. What is the difference? In primitive rectangular lattice, A is not equal to B, gamma is equal to 90 degree, and also there is no extra lattice point at the center. But in the case of centered rectangular lattice, A is not equal to B, gamma is equal to 90 degree, but there is a lattice point at the center. You will see these differences in the figure in the coming slides. Okay, so primitive rectangular lattice, centered rectangular lattice. What is the difference? A is not equal to B but gamma equal to 90 degree in the case of primitive rectangular lattice. A is not equal to B but gamma is equal to 90 degree, but there is an extra lattice point at the center, then it is called a centered rectangular lattice. Now, primitive rectangular lattice. What is primitive rectangular lattice? A is not equal to B and gamma equal to 90. I already told these things. A is not equal to B and gamma equal to 90 degree. A is not equal to B and gamma equal to 90 degree, but there is an extra point, then it is called centered rectangular lattice. But here in a centered rectangular lattice, A is not equal to B and gamma is equal to 90 degree, but there is an extra point. So this is the difference between primitive rectangular lattice and centered rectangular lattice. What is hexagonal lattice? A is equal to B but gamma is equal to 120 degree. All other lattices, other four lattices are below 90 degree or equal to 90 degree, but in hexagonal lattice A is equal to B and gamma is equal to 120 degree. Okay, so these are the 5 types of 2D Bravais lattices. So what are the 2D Bravais lattices? Oblique lattice, square or rectangular lattice, primitive rectangular lattice, centered rectangular lattice and hexagonal lattice. So these are the 5 two-dimensional Bravais lattices. Now you see, this is the image, this is the figure. you see the square lattice, that is A is equal to B. If this is A and this is B, then the length of A and B are same, and this angle is represented as gamma, and it should be 90 degree. You see, it is 90 degree. What is a hexagonal lattice? Or here you see rectangular or primitive lattice. First, rectangular primitive. A is not equal to B, gamma is equal to 90 degree, but there will be a center lattice point. You see here, you take this example, A is not equal to B, but this is 90 degree, called rectangular primitive lattice. Here you see the example, A is not equal to B. Here the length of A is greater than B, and you see the angle, it is also 90 degree, but there is a center lattice point. So this is the difference between primitive lattice and centered rectangular lattice. So square lattice, primitive and centered rectangular lattice. Here you see what is oblique lattice. A is not equal to B, and also gamma is not equal to 90 degree. If like this, then it is called a oblique lattice. What is hexagonal lattice? A is equal to B. Here some lattice points is also there, but in this figure they dropped only 2 points. Here also 1 point. You join this point. Here A and B are same, and this angle is 120 degree. Here this angle is 90 degree. This angle is 120 degree. This is called hexagonal lattice. So this is the structural or pictorial representation of square lattice, oblique lattice, rectangular primitive lattice, rectangular centered lattice, then hexagonal lattice. Okay, so these are the pictorial representation of two-dimensional Bravais lattices. Normally when they are asking in an exam, you should write this definition for square lattice, and also you draw this figure also. This figure is must for getting more marks. Okay, right, you understand the things now. Now we will see Bravais lattice in 3 dimensions. In 3 dimension, there are 7 types of systems, but 14 types of Bravais lattices in the 3 dimension. So in the 3 dimension, there are 14 types of Bravais systems, Bravais lattices, and there are 7 types of systems: cubic, tetragonal, orthorhombic, monoclinic, triclinic, trigonal, hexagonal. So what is cubic? You know, the example of a cube is a cube or a box. These are the example of a cubic system. In a cubic system, there are 3 types: simple cubic, face-centered cubic, body-centered cubic. Simple cubic, face-centered cubic, body-centered cubic. You already read all these things maybe in your earlier classes. As a simple cubic is represented by the letter SC. Face-centered cubic crystal is represented by the letter FCC, and body-centered may be represented as BCC. I think this was you may read in the earlier classes in +2 or +1. Maybe you may read these things. So cubic system. Cubic means what? A is equal to B is equal to C. All the 3 sides are equal, and all the 3 angles are same. Alpha, beta, gamma is equal to 90 degree. That means that's why it is represented represented as a 3D system. There will be x-axis, y-axis, z-axis, or there will be A, B, C lengths, and there will be 3 angles alpha, beta and gamma. Therefore, it is called as a 3 dimension. Okay. So, in cubic system, there are 3 number of lattices. In tetragonal, there are 2 number of lattices, simple tetragonal, body centered tetragonal. Here A is equal to B but not equal to C, but alpha, beta, gamma is equal to 90 degree. You see, when you are studying the things, I made this in a tabular column, so it is very easy for you peoples to read the things and understand the things easily. Here you see A is equal to B is equal to C, alpha is equal to beta equal to gamma equal to 90 degree, then it is a cubic system. There are 3 number of lattices. What are 3 number? Simple cubic, face centered cubic, body centered cubic. Tetragonal means there are 2 systems, simple tetragonal, body centered tetragonal. Here you see A is equal to B is not equal to C, it is the difference here. Then alpha, beta, gamma equal to 90 degree, then it is a tetragonal system. What is the orthorhombic system? There will be 4 lattices, Bravais lattices. Here you see A is not equal to B is not equal to C. All the 3 lengths are different, but all the 3 angles are equal to 90 degree, then it is called orthorhombic. Simple orthorhombic, body centered orthorhombic, base centered orthorhombic, face centered orthorhombic. So there are 4 systems. Here you see, what do you mean by face centered, what is body centered? If there will be a body in a simple cubic system, there will be 2 body, there is a body. If a lattice point at the center of the body, then it is called a body centered. If the lattice points at the face centers, then it is called face centered. If the lattice points are at the base, then it is a base centered. We will see the differences in the next slide with a pictorial representation. Then you may understand easily. Okay, right. So orthorhombic. Then monoclinic. A is not equal to B is not equal to C. Alpha is equal to gamma is equal to 90 degree, beta is not equal to 90 degree. Here you see orthorhombic and monoclinic. ABC are not equal, ABC are not equal, but alpha, beta, gamma equal to 90 degree. But in the case of monoclinic, ABC are not equal, alpha and gamma angles are same, but beta angle is different. Mono means single, so there will be a single difference, therefore it is called as monoclinic. Now you understand what is a triclinic. You see, A is not equal to B is not equal to C, but alpha is not equal to beta, is not equal to gamma, is not equal to 90. So all the 3 angles are different, hence it is called as triclinic structure. Trigonal or rhombohedral structure. A is equal to B is equal to C, alpha is equal to beta is equal to gamma, but less than 120 degree, but not 90 degree. If it is equal to 90 degree, then it will become cubic system. You see, A, B, C are all same, alpha, beta, gamma are all 90 degree, but here A, B, C are same, but alpha, beta, gamma are less than 120 but not 90 degree. You may consider if alpha is equal to 80, beta equal to 80, gamma is also equal to 80, less than 120. Okay, then it is a trigonal. A, B, C are same, then it is a trigonal or rhombohedral. What is hexagonal? A, B are same, but C is not the same. Alpha, beta 90 degree, gamma is 120 degree. Then it is called hexagonal. You see, tetragonal and hexagonal. In tetragonal, A is equal to B is not equal to C, but alpha, beta, gamma is 90 degree. Here you see A is equal to B is not equal to C, it is okay. But here you see the difference, alpha is equal to beta is equal to 90 degree, gamma is equal to 120 degree. So this is the difference between hexagonal and tetragonal. Therefore, there will be 7 systems, 7 types of system: cubic, tetragonal, orthorhombic, monoclinic, triclinic, trigonal, hexagonal, and there will be 14 types of lattices, Bravais lattices, 7 types of systems and 14 types of Bravais lattices. This is the pictorial representation of Bravais lattices in 3 dimension. So you see, we know already there are 7 types: cubic type, tetragonal type, orthorhombic type, rhombohedral, hexagonal, monoclinic and triclinic. So there are 7 types and 14 systems, Bravais lattices. This is the pictorial representation. You see, cubic system. In cubic system, all the atoms or all the lattice points at the corners of a cube. Body centered means there is, you see here, a center point. At the center of the body there is a lattice point, hence it is called as body centered cubic crystal. What is a face centered? In a cube there are 6 faces. Each face has a center lattice point, therefore it is called as a face centered cubic crystal. So simple cubic, body centered, face centered. You understand? Now you may understand the pictorial representation of this simple cubic system: body centered cubic system, face centered cubic system. What is a tetragonal? You see, this is the tetragonal shape and there is a point at the body center, so it is a body centered tetragonal. Orthorhombic, there are 4 types of orthorhombic: simple, then body centered. You see here one lattice point at the body, at the center of the body. Then base centered. Here there are 2 types of bases in the orthorhombic system. So for this base, here one lattice point. For this space, here one lattice point. Therefore it is a base centered orthorhombic. Face centered orthorhombic, all the faces at the center there is a lattice points, hence it is called as face centered orthorhombic. Then rhombohedral shape, this is the hexagonal shape, 120 degree, angle is 120 degree. Then this is a simple monoclinic, A is equal to B is equal to C, but alpha is equal to beta is equal to one angle, gamma is different angle, then it is called a simple monoclinic. But in the triclinic, all are different, therefore it is called as triclinic system. So how the angle and how the sides will differ, you read in the earlier slide. So this is the pictorial representation of simple cubic, body centered cubic, face centered, that is 3D Bravais lattice systems. Okay, you understand? Okay, so in this class we read about bodies, what do you mean by Bravais lattices, and what is a 2-dimensional Bravais lattice and what is 3-dimensional Bravais lattices. In 2-dimensional Bravais lattice there are 5 types. In 3-dimensional Bravais lattices there are 14 types, that is 7 structural. In among 7 it has 14 Bravais lattices. So you read about all 5 2-dimensional Bravais lattices and 14 3-dimensional Bravais lattices. So this is an important question. You read the things and be safe. I will meet you with another topic in the next class. Okay, have a nice day. Thank you.